one.
Hey Unicode, really glad to be with you today. I'm Kelsey Nabin, a researcher at RMIT University, and I'm joined by Michael Zager, founder and CEO of BlockScience. And we're here to talk about the foundations of decentralized governance. So the aim of this presentation is to draw on control theory to explore governance dynamics in decentralized, complex, adaptive systems. So first of all, it's worth starting off by questioning, what is governance? What are we talking about when we say governance, and how is it delineated from politics or political processes or a lot of other sort of related but distinct themes? And so in order to define this, we're drawing on the definition from French philosopher Michel Foucault, who describes governance as the art of governing or governmentality in a democratic society as the techniques and procedures for directing human behavior. So this is a helpful way of thinking about governance in decentralized systems, as well as the process of structuring the possible field of action for others. Michael, do you want to comment on that?
Sure, yeah, I think it's important to examine what this looks like in both a sort of top-down and a participatory system. So a lot of the times when we think about governance, we think about the specific decision like being enacted, or the process through which that decision is enacted. And in a top-down system, it might be as simple as, someone with the authority to set the field of action for others simply does it and revises it sort of on a whim. In fact, I'm sure we've all experienced that in some sorts of digital, largely Web 2 systems, where what we're allowed to do, what we can see, is the province of the platform provider. As we move into understanding more decentralized systems, or in particular systems with feedback loops between the participants within those systems, or the users within those systems, and the field of action available to them, that's where we start to examine the complexity of adhering to the field of action as it is versus changing it in the future. And so we can start to examine the processes beyond just the point of decision and expand them to understanding the relationships between the sort of role as participant and the role as governor, especially if these things overlap, which is actually pretty common in a decentralized system.
So that's actually a really nice delineation of what is a DAO, and actually understanding the difference between an organization and a set of tools. Because if governance is structuring the field of action, we're not talking about a DAO as a multi-sig, a snapshot, and liquid token delegation. We're saying fundamentally the most basic DAO is a set of participants and an objective. And so the first step is to make those kind of often implicit assumptions explicit and start to think about how they then apply to governance within that system.
So I think in order to dig into this, we should examine another concept that we've been exploring in our research, and that concept is the governance surface. So if you are doing governance to set the field of action, then there's a sort of field of action for setting the field of action. Now that sounds sort of silly, but we just decompose it a little bit. As an actor within a system, you have some things you can do and some things that you can see, and generally a way of engaging with that system. But in a governance role, whether it's a decentralized or a centralized governance role, there's generally a set of actions that you can take to change that field of action. Now, if networks such as crypto networks or software systems that enable people to do stuff. Generally, this means software is the field of action. You're pushing changes to code, or you're pushing changes to parameters that are in code, or possibly you're expending funds to maintain or develop future features. There's a range of activities, but if there's a set of actions that you can take as part of the platform, there's also a set of actions that you can take to evolve the platform. And so we tend to delineate the governance surface as the set of things that the governance activity can do. And even that might need to be further broken down because you might use different processes or have different stakeholders who have rights over, say, the governance of a pool of funds versus, say, the governance of a particular parameter within a piece of software versus the governance of the software writ large, where you could imagine making arbitrary changes to code. And so anytime that you need to say, this group of stakeholders through this process has control over these parameters or these activities which further structure the field of action for everyone else, then we can call that a governance surface. So there isn't necessarily a specific one governance surface for an organization, but anytime we want to look at a governance activity, we can examine what's the set of rules for changing what particular aspects of that system. Kelsey, did you have anything?
That. Yeah, I really like that. And it obviously then differs between different organizations as well, or different DAOs, or whatever the system you're looking at is. So there's not just one governance surface, but then that will also differ across different organizations. And I think what you mentioned at the start there, in terms of kind of creating a mental model or a conceptual model of what that governance surface is according to the relevant decision, that also requires the designer or the governors to be self-aware and factor themselves and their sort of position and relationship in relation to what they are governing into that picture as well, which is really interesting.
Yeah, we have to ask sort of, when we move towards participatory or decentralized governance, what does it mean to become informed in order to participate in that process? Because I think we often take governance as a big bucket. And the truth is that an informed participant in governance depends a lot on what they're governing. And so in the case of breaking things down, or in the case of decentralized governance, it's necessary to break things down so that we can better understand which participants have control over which governance surfaces and how we can move towards a informed participatory governance, as opposed to just governance, I checked the box, cool, we let people participate, so it's totally going to work. I think we see a lot of that.
Yeah, I mean, as an ethnographer and a social scientist in this space, this is something that multiple DAOs are grappling with, in terms of how do you have a participatory system where everyone has a say in decision making, but then how do you have a meritocracy as well? So how do you have people that are informed on a specific matter, whether it is technical or fiscal or something else, actually having authority to make decisions on the relevant matters? And so there's kind of still that tension, I think, as communities experiment with figuring out governance and then decentralized governance, in terms of, is it everyone makes decisions on everything, or is it the most qualified make decisions on some things, but then how is that actually going to prevent against kind of collusion or attack or you know, undue
Who
control
decides
or
who's
influence?
qualified, right?
Exactly, the age-old problem about how you decentralize the system, who decides.
So I think it's probably time to get into one of the more formal concepts. This is borrowed from control theory, which is the area of my PhD work. For those who aren't familiar, I'm a control theorist specializing in actually decentralized systems. That's what my PhD work was on. And here we're going to bring in a pretty basic concept from, like, intro undergraduate classes on control theory. And that concept is called controllability and observability. Really, it's two concepts, but they are kind of pairs. They're a pair that come together. And so I'm going to give a quick overview of the two concepts, and then we're going to explore how it is relevant to organizations. So in control theory, we have a system that's being built, or generally something that already exists, called the plant. And the plant is a system that you want to steer. However, it's there already, and you need to add actuators and sensors. Actuators are the means of changing the system, and sensors are the means of observing the system. Now, most systems are not completely actuated and completely visible. Some aspects are going to be measurable, meaning you can see what's going on. Some aspects are going to be unmeasurable, but you might be able to make inferences about them from what you can measure. Similarly, you want to control some of the states of the system, but you can't necessarily just set the thing to the point you want. You actually have to steer. You need to accelerate your car. You need to turn the steering wheel. And those controls allow you to collectively navigate the car to where you want it to go, without necessarily just mutating its state to the car is in front of my house, or the car is in front of my, or in the parking lot at the university, etc. So we break down these concepts of observability and controllability in order to determine whether it is possible to navigate a system from where it is to where we want it to be in a sort of abstract space, not necessarily just physical space. And we do this by adding things that allow us to mutate the state of the system and to measure the current state of the system. And in an organization, the sensors are going to look like places where you can collect data, where you can measure progress against KPIs. Not necessarily the KPIs, which are higher level goals, but the measurements that you take in order to determine whether you're meeting your KPIs. And so what ends up happening then is that you look at your system and you provision some measurement apparatus and some mutation or change apparatus, and then you feed that output back into a controller. And a controller is just a decision-making system. It perceives what it can observe, and it uses that to actuate through the tools that it has. So in the context of decentralized governance, what we're really just saying is that the organization writ large needs to be able to set some goals. It needs to be able to measure its progress in those goals. And then it needs to make decisions about how to use the levers, the actuators under its control to make changes in the system, which they can then observe through the sensors. Part of what makes this difficult is that there's often big time lags, right? So activities that you might take in the short term to drive your goals in the long term might be counterintuitive or opposite what you might expect. This is because the system itself has dynamics, maybe some that you don't even know. And so you have to respond to perturbations or uncertain elements in a proactive way, not just in a reactive way, in order to drive towards your goals. And I'm going to sort of leave this at that for the moment. If you're interested more in these concepts, I would recommend this YouTube video that we've linked, just talking about the basics of observability and controllability and how you provision actuators and sensors for physical systems in order to learn to drive them towards desired outputs. And I'm going to note that we are not really doing the sort of undergraduate version of this in our decentralized organizations and our decentralized governance problems. We're really doing the multi-agent version of this, whole teams of individuals each observing things independently and sharing some access to a collection of actuators. And we need to get this system to steer as a swarm rather than steer as a centralized sort of command and control architecture if we want to be able to think about this as sort of decentralized governance, not just as centralized governance. Kelsey, I know I've been talking for a long time here. Do you want to sort of layer in some interpretation of how this fits into our like social systems, DAO governance design problems?
Yeah, absolutely. And it's really helpful. The way that I think about those concepts coming not from the control theory background is controllability is what levers of control are there in the system. And then when we map that to DAOs, it's who gets to manage those levers. And then observability. So how can the behavior of the system be observed and measured? And again, like who gets to observe and who decides what's happening in the system, and then who then, in that loop, who comes back to the levers, controllability and controls, and then who observes and so on. And so, I mean, practically, these concepts lead to really concrete questions that are hyper relevant to design in DAOs. So what in the system is controllable? So what can be influenced? And what is observable? How do we know what kind of critical changes occur in the system and the outputs of those between different states? And then if it is controllable and observable, how much so? From there, what are the effective places to add sensors? So you mentioned we need to kind of measure the states and the outputs to generate those feedback loops, but where and how do we do that? And then the actuators as well. So what are the suitable places and how much effort or force needs to go into those? And so I think one of the most helpful analogies for these concepts is one that you actually shared with me, Zagam, around a car. And so that might take us to our next slide in terms of the size of the governance surface.
Yeah, I will make one comment before we go all the way into sizing the governance surface, and that's that measurement is tricky. And I think it's something that we'll be addressing in some of our other writings, but especially with social science, like science, and the lack of explicit measurables in terms of the things that are our real goals, we're always going to run into challenges determining what our sensors are. The sensors themselves are actually proxies for the underlying phenomena. And so, as a flag for people who are taking this as advice to go plan out their ways of, guiding their organizations, I want to put a reminder that your measurements are always reductions. They're always samplings from the phenomena that you're trying to drive. And so you should always be careful about what you measure, how you measure it, and how you use those measurements, because you might argue that a really important part of your governance surface is actually deciding what your goals are and deciding how to measure those goals, because minor changes in what your measurement apparatus is can actually greatly impact the output decisions about what to do. And that means it's part of governance.
Great. So we get to governance surface, and I think the common, or like a common kind of thought pattern in decentralized systems is that smaller is better. So keep governance really simple so it's controllable, or through the process of trying to, I guess, decentralize or simplify, it's automate as much as possible. So it's free from kind of the vulnerabilities that human intervention might introduce. But coming back to that car analogy, the way that I understand it is there's a certain amount of control that you would like in a car, and observability. So control is, it must have a steering wheel, a gas pedal, a brake, and a gearbox. You actually don't want less governance than that. And then in terms of observability, you definitely want a windshield, you definitely want side mirrors, you definitely want, a dashboard with your speedometer and all those things. And so I think that analogy is helpful when thinking about governance, because it's not about making it small or automating it or making it big, but perhaps you can talk more to the concept of this idea of right sizing.
Yeah, I think the thing to understand is that the amount of actuators that you need depend on what you want to be able to accomplish. So we can think about the car analogy, and we could imagine what would happen if we cut the brakes, so to speak, right? You would lose a degree of control over the vehicle that would be really unhelpful. In fact, it'd become much more difficult to accomplish goals of getting the car to where you want it to be if you could only use the gas, but you probably still could. So like technically speaking, I think you'd retain sort of controllability of the navigation of the 2D plane of the traffic transportation system, but it would become much more difficult. It would be less safe, probably. If you also took away the gas, you would lose your ability to actually modulate your velocity, and thus you wouldn't really be able to control position, even if you could, say, change the steering wheel. You might be at a fixed velocity, but you'd be, in the worst case, just sort of going around in circles. Sort of annoying, silly maybe, but the point here is that leaving the gas and the brake, but removing the steering wheel would also reduce your capacity to navigate somewhere. Now, all along, we're assuming you can see out the window, see where you're going, maybe that you have a speedometer so that you can keep track of what speed you're moving at, and imagine what it would be like to try to navigate that same car without the visibility of being able to see out the window or be able to see your current speed. It's the combination of those observables and those actuators that basically render a car as a useful piece of technology that you as the driver can sort of navigate the gestalt of you plus the machine to where you want it to be. Now, one of the interesting elements of this discussion, the car analogy, is it does beg questions about quote unquote autonomous vehicles. And what's really interesting about it is that the car is only really about as autonomous with, say, the technology that allows it to drive as it is with you in it from a first principles perspective, because it needs you to give it a target destination. So I guess a person plus the car is autonomous in the sense that the person gives the car instructions and the car delivers on those instructions. That's technically true, even if you're not in the vehicle driving it, because you're setting the destination, or a human is setting the destination for the autonomous car. That's a little bit silly, but I want to point out the fact that these technologies and their relationships with humans, excuse me, require us to think about where the goals are coming from. And so maybe without going too far down that rabbit hole, I'd like to point out that when we're sizing the governance surface, we are really working backwards from those goals. If I had really an autonomous car, then my governance surface has been reduced to basically giving the car instructions about where to take me. If I'm the driver of the car, then my governance surface is the pedal and the brakes and the steering wheel, etc. And in both cases, we are working with the same vehicle. We've just changed the amount of control being exercised directly by the humans, or in this case, the humans that are overseeing that system. And what I want to point out is that the lower level mechanisms associated with the brake and the gas and the steering and the gearbox are actually still there. Even when we automated up, we are just automating the use of those now lower level mechanisms. So we're just stacking things up. And when we automate, that can work as a great way to reduce the governance surface, but it never wholly eliminates the sort of human at the top of the stack, because no matter how much you move up, you're going to need someone to do some goal setting. You could even have a whole fleet of autonomous cars that are taking their guidance in terms of the goal on up another level. And you could have, a continued stacking that ultimately gives up to some profit objective over some measurement over some other, again, higher and higher order goal. But when we think about governance, we can think of it as saying we keep pushing the goal setting, the field of action structuring up to a higher and higher level composite. But we've never really lost the degrees of observability and controllability in the lower level systems. We've just made the governing apparatus a higher level software system. And I like to emphasize this with regards to DAOs, and in particular, decentralized governance, because we're trying to ensure that the top level of the stack of governing apparatus actually points back around at the constituents of that system. And it could end up being a pretty complex network of expertises and empowering of different humans to monitor, maintain, or govern different pieces of such an assemblage. But if we want to think in a participatory way or in a decentralized governance way, it does make sense to ensure that there's always a loop back around to the automated, the higher level decision-making apparatus, where its measurements and its goals can be changed by the humans who are subjected to the decisions that automation is making. Kelsey, do you want to add anything before we move on to the next slide?
It's a well articulated point. And I think that takes us to the next slide in many ways. It's a whole a whole other presentation, but this idea of autonomy in what we know and love as decentralized autonomous systems has kind of been a bit of an obsession for me this year. And I have a post on my Substack blog in terms of this, asking who or what is being made autonomous in autonomous systems. So I think that point about automation, but still the role of people in systems is really important. And so it kind of brings us to this question of like, what is actually the objective of governance? And I don't, from what I sort of have researched, I don't see this super well articulated within decentralized technology communities thus far, I guess. And so we talk about them as evolutionary, but it's a really important question in terms of like, what are we evolving towards, or what's the aspiration here? And so I really like the definition of autonomy that comes out of the field of cybernetics, informed by control theory, which is what we've been talking about, which is this idea of wholeness. And so, Zagam, you've actually been bringing up for a while that DAOs could think of themselves as autopoietic systems. And what this means is just a fancy word for saying a living organism, or something that is able to make decisions, adapt, evolve, and even sort of self-perpetuate or kind of like replicate itself without relying on external resources per se. So that's kind of perhaps an interesting thought provoker, but there's some really great, quite old school kind of literature on that. And I highly recommend someone called Varela from the 1970s, who talks about autopoietic systems and how something that is autopoietic is whole in and of itself. And thus that wholeness, meaning that it doesn't depend on any external factors, is actually autonomy. And that's quite a nice way of thinking about what autonomy could mean in decentralized autonomous organizations.
One of my favorite ways of articulating autopoiesis is as constantly in the process of creating itself, because it's not static. I think this is probably the biggest leap from autonomy to autopoietic that's relevant for DAOs, is that when we think autonomous, especially in a very technical sense, like a closed loop control system that observes, decides, acts, observes, decides, acts, and this is perpetuated, it's dynamic in one level, meaning it's got feedback. Generally, this is feedback control, right? The basis of the control theory literature is the idea that you can go through this process of observing state through sensors and using it to make decisions in pursuit of an objective, to execute on those decisions and observe, even if things don't go as intended. You're continuously able to adapt to the changes within the scope of that model. However, they tend to be static up one level, in the sense that there's not really a meaningful way to change its goal unless you stack it with another such system. And we get back to what I said on the previous slide about sort of the human at the top of the stack somewhere setting some goals. In an autopoietic system, the source of the goal setting is also internal. And so we've moved beyond just saying that the system is closed in the sort of informational technical sense around pursuing an objective, but it's closed on itself in a higher order way, meaning it's able to discover and sort of, rewire or continuously create itself. And that sounds like kind of wishy-washy stuff, but I think if we examine a particular DAO that I feel exhibits this property, it becomes a little bit more concrete. So I've been a contributor to the DAO called Onehive. It's a sort of self-organizing system built on the Aragon stack. And in particular, the Onehive DAO instance that's running, or the community that's got their infrastructure running on the XDAI network has evolved it multiple times. They have many swarms that are independently operating, living. Some of them get big and even fork off into multiple organizations or even other organizations. They get funding through a shared voting scheme. But what's so interesting about it is they've actually made upgrades to their code. They've spun out other sub organizations that became their own organizations, and they exhibit a lot more of the properties that I associate with sort of living organisms, albeit they are code plus humans doing things that interest them. What interests them has changed over time. Their software infrastructure has evolved with the deployment of new smart contracts. And basically, if you trace the lineage of the project, you'll see ebbs and flows in people, ebbs and flows in code bases, variations in a plurality of objectives pursued by the different swarms, and as I noted, spin-offs of projects that grew out of it. So that kind of situation lends us to believe that it is possible to look at the gestalt of the humans and the infrastructure that they're using as a whole entity in its own right, and that entity is able to adapt its goals. But unlike some of the more centralized sort of stackings, like in the autonomous car or even the fleet of autonomous cars example, it doesn't loop back around on like a single point of decision making. It actually loops around through a collective decision making process. And the participants within that system have sort of emerged this plurality of objectives that are largely complementary, but they are fuzzier and less bottlenecked on a single point of decision making than some of the more technical examples and even some of the more technical articulations of the control of DAOs.
Yeah, a couple more points that come up in relation to Onehive as a kind of sort of case study example, and I'm really grateful to members of that community for engaging in research interviews. But the decentralization of that system comes from the fact that no one is setting the kind of high level strategic direction, although there are shared sort of vision and goals which give the participants in the system the capacity to set their own objectives, I guess, or subsets of objectives. And so a couple of things happen there within the design of the system. And one is that value is intrinsic to the ecosystem, to the way that currency is automatically minted through the smart contract and then deployed through proposals to reward labor in that system, means that even value in that ecosystem is not pegged to any external kind of real world currency, although Honey token found its way to currencies and kind of can be mapped to a US dollar value or whatever. The other is in the way that the system sort of self recreates or perpetuates. It's not just when mechanisms are built by swarms within the system, such as adding on different modules, but actually the high level architecture of how that ecosystem runs was recently sort of adopted, I guess. I was going to say forked, but it was adopted by Bright ID. So actually it's creating an evolution of itself, or it's self reproducing, but in a different instantiation, which is really interesting when it comes back again to that idea of autonomy and wholeness. And I think just zooming out and linking to something I said in the first slide is what we wanted to kind of start to explore was how governance differs from other or is distinct from other concepts we see in decentralized autonomous organizations and decentralized systems. And so the way that we've spoken about this and some of the concepts we've tried to draw out are very different from politics, for example, or political processes. But when we come back to, a whole system that is, self-governing, independent of external factors, and this, governance surface and controllability and observability are some of the techniques used to do that, it's very different from things that run on top of the governance surface, and also things that run underneath it, such as the fundamental kind of architecture that you've spoken about a couple of times, Argham, and how people sort of sit at the top of those layers.
Yeah, I want to make a comment about the relationship between governance and politics, especially within the scope of this concept, the governance surface. So if the governance surface is the set of actions that governance can take, it's meant to encode a feasible set. So from in a formal decision problem, an optimization problem of sorts, there's a feasibility, and then there's like the objective or the goal. What would make something optimal is the thing that is the highest value in the objective function, suppose you're maximizing, and it has to be a point in the decision surface, or the set of decision variables that are feasible. And what's interesting about the governance surface is that it actually encodes the feasible actions, or the things that can be done, not the measurement of whether that's the right thing to do. And in an environment that's decentralized, there isn't necessarily a unique objective. The objective is a composite of all of the stakeholders who have governance authority or rights in choosing a point from the set of feasible governance actions. And so as we leverage that sort of decision-making formalism that comes from the theory of optimization, and which is implicit in much of control theory, we're realizing that by decomposing the concept of a feasible action, or the set of actions that can be taken, from the specific action that is taken or is even proposed to be taken, we've opened up room for an evaluation of a political process in terms of how candidate actions from the feasible set are surfaced and evaluated and discussed, and then ultimately sort of ratified and put into action, and then even the consequences of observed and feedback on future decisions. But because we've decomposed the governance surface as a set of possible actions from any specific action taken, we've actually left room to discover or even realize the preferences of the community through their actions in the governance process, or in a political process that gives rise to the choice of an action through a governance process. And so there's definitely a lot of meat that could be further untangled in these concepts, but as Kelsey mentioned earlier, we're not actually doing this for the first time. There is a many decade old theory called cybernetics, which itself examines the application of control theory to decision making in organizations and large institutions, with the caveat that early cybernetics was very top down, very command and control. And part of the application of cybernetics to decentralized governance is moving away from that command and control view and leveraging concepts from decentralized control theory to understand how to accomplish a informed participatory governance through feedback loops within these living systems.
So perhaps that takes us to our next slide, to say that we do have a research piece coming on this, which explains these details or these concepts in more detail, and also goes into the case study and as a kind of applied example. So we'd love to share that with you when it's ready. And thank you so much to Unicode for having us, and the organizers as well for the invitation. Really appreciate it.
Thank you very much. And a shout out to our teams. I work with a great team of researchers at BlockScience, and Kelsey with a great team at RMIT. Anything else you want to add?
Hope to engage with people, I guess. Feel free to reach out to discuss further.
Awesome. Thank you.